All right, today is our last day of review, and I'm going to give you a couple of word problems to do that are like longer, tougher, and we're going to work them all the way out. But before we do that, I want to talk about some common mistakes in setup. All right, so one of the things you have to be able to do is draw the pictures properly. And I'm going to tell you a little story, this is true, about how like sometimes we've had lampposts and the lamppost has a shadow and all that kind of stuff. Well, something I was thinking of that would be kind of a cool thing with a shadow is you can stick a stick in your backyard where it can get sun shining on it, okay? And if you have it tilt at an angle that is the same as the latitude that you are at. Okay, now in Minnesota here, in the Twin Cities area, we are at about 45 degrees. It's 44 point something. And so I'm going to round it to about 45 degrees. So you want to take your stick and tilt it at a 45-degree angle. And then, this is important, it has to be tilted at a 45-degree angle and pointing north. Okay, I have since double-checked and figured out that in this room, north is in that direction. Okay, and so if I were to take this stick, stick it in my backyard, and have it be tilting at a 45-degree angle towards north, then as the sun rises and sets, it will cause the shadow from this stick, which will of course kind of look like a stick, right? The shadow will actually move in a circle around, and it'll make a nice round circle. And if you were to put out a little rock each hour and set a rock where the tip of the stick is pointing, you would find that you make a perfect little circle around your stick. And think about it, the sun isn't shining for that many hours in Minnesota, but it's not going to have 24 little rocks. It's not going to be a 24-hour circle. It actually goes around in like a clock. So anyway, it's called a sundial, and you can make one in your backyard by doing that. And again, you just got to remember it's about 45-degree angle, and that you got to tilt it towards north. And then every hour, go out and put a little rock. Try it. It's pretty cool. All right. Now, for our setup for this problem, the kid goes out and sticks a stick in the backyard and tilts it, but they misunderstood me and they just tilt it toward the sun. Okay? Draw that. It will cast a shadow, which of course the shadow will be on the opposite side from the sun. And let's all agree to have the sun on the left-hand side. I know you probably put it on the right hand, but then your drawing will be the same as mine if we have it on the left-hand side. Sun's shining up there. Stick tilting toward the sun, where it really shouldn't be. Which way should it be tilting? North. Okay, good. And they remembered the 45-degree angle part, so it's tilted toward the sun at a 45-degree angle. All right, what are some key elements? You should have the ground, because that's going to be part of a triangle. Eventually a right triangle, but for right now it's not going to be a right triangle. And then you have your stick, and he said tilted toward the sun, and this was 45. And then the shadow would be not here. The sun shines against the stick and puts the shadow out that way. Okay? Now, maybe my sun's a little too high in the sky for you to see how this would be. Now, of course, it's true. If we were to let the sun move across the sky, eventually the shadow would move, right? But for now, anyway, one more piece. The angle of elevation from the tip of the shadow to the top of the stick is 10 degrees. One more thing, 10-degree angle of elevation, is that the stick in this case is going to be 3 feet long. It's a meter stick like this. Meter sticks aren't actually 3 feet long. Meter sticks are, how many inches do you know? About 39 inches instead of 36. That leaves just enough to shove in the ground, right? So we can still have a 3-foot long stick. All right, so did you label this properly? And what was the angle of elevation? So 10 goes right there. Raise your hand if you drew that properly. Okay, good. Now, let me give you another one and talk about setup. But before we move on, do you get we did not draw a right triangle here? But do you get that there are other triangles nearby that are right triangles that might help you? And even more important than, yeah, there's a right triangle here and everybody knows it's 45, 45, 90. That's probably important. But do you get that you could have taken the red triangle and drawn a line that it would have divided it into two triangles? That's probably one of the best ways to do these. Can you please take the triangle that you have drawn and draw a line that breaks it into two right triangles? It's very tempting to just make one of them a nice right triangle and then the other one you just kind of let go. For instance, right here, bad place to make a right triangle. Yes, you've made a right triangle now, but look at the other triangle. It's not a right triangle. So you've got to be careful how you do it. Did you find that spot right there? It would allow you to make it into two right triangles. And then each of them you can do trig on them if you have one side and one angle. And it's often not super clear. Well, obviously we have a side that's 3. That's really easy, but it's hard to find the proper angle within that triangle. So it's not like instantly obvious of exactly what that angle is or exactly what that angle is. But maybe you can figure it out by using the other triangle. Maybe this guy can help you figure out what the angles are. In that triangle, do you get if this one's 10? What's that one got to be? We just drew it to be a what? A 90. Okay, so if that's a 90 and that's a 10, then what's that one got to be? 80. And do you get if that one's 80 and this one's 45, can you get how you could figure out that one? This one's 45 and this one's 80. The only thing that's left is this red one right here. And anyway, the point is the answers aren't instantly there, but you got to jump around from one place to the other and say, oh, if this is logically that, then this has to logically be that. And you end up jumping around the problem and filling it in. All right, now let's do one where it's a walking kind of a question. So you're walking around in a park and you're trying to do geocaching. You know what that is? You find stuff that's been hidden at certain latitudes and longitudes, and there's some crazy ones where people have hidden things like way out between campsites in the boundary waters. So you're like hiking through the woods in the almost up by Canada in the middle of nowhere, and then they hide this little jar. Anyway, so you are walking through a park and you head at a bearing of 40 degrees. Right away, you should know how to draw that. 40-degree bearing. That's all you know so far. Question, did you start with a compass rose? Good, then you have been trained well. If you didn't, it's my fault and I apologize. All right, 40 degrees means from here, 40. And all of a sudden, you know a ton of stuff. Already you know a ton of stuff. This is a 90. Obviously, the other ones are 90. If that's 40, then how much is this? 50. And then if I wanted to extend this through the compass rose, I could, and that would keep this and this the same, and that'd be 40, and that'd be 50. I mean, you know a gajillion things from what I just said. All right, so anyway, you have headed at a 40-degree bearing. Let's say that you walk for 200 feet that way. And then you realize that you were off course on your geocaching thing, and you start heading, let's go with one of those north 20 degrees west thingy bobs. In fact, let's do that one, north, but 20 degrees west. First we went 200 feet at a bearing of 40. True. Now we're going to go 400 feet at a bearing of north. What did I say? What? How many degrees?
40 degrees.
What? 20? I thought Okay, 20 degrees. Did I say west or east? West. All right. North, 20 degrees west. Okay, it's time to once again think about whether you did the kind of the standard operating procedure, which is to put another compass rose right there. Did you have another compass rose right there? Okay, good. Then from here, I was generally headed north, but I got to swing it to the west 20 degrees. So I'm going to go that way where that's 20. And then again, I'm going to put another compass rose up here. Well, wait, I should get my miles straight here, or my feet. This was 200, this one's 400, so it's quite a bit longer than the way I've portrayed it. That's 200, that's like 400. All right, now this one's a particularly tough one because it's hard to tell whether this just comes straight down or it doesn't look like it comes straight down. It looks like it comes back a little bit. But again, that's just a matter of how I set up this problem. We're not going to have any that are obscure, it's really hard to tell, but you are pretty much never given a right triangle. But you can make right triangles. Go ahead and draw. Try to do that kind, instead of going around the outside, I know there's 3 right triangles around this thing. Try to go through the middle. Figure out where you could draw a line that would divide them up into 2 right triangles. Did you say something like that? Okay, that would make 2 right triangles. Idea being that's a right, didn't work, hold on. That's a right angle, and that's a right angle. Okay, now I have 2 problems that are well thought out and come out to, like, they don't come out to perfect answers or anything, but they work so that you can see that they're, like this one I don't like very much. I just did it off on the fly. But the reason I don't like it is this green line, it's really hard to tell whether that's a vertical line or not. Should it be tilted this way or that way? The problems that you're going to do today in class are clear and well thought out. Now that one was just meant to remind you of the bearing type of question. What else could be on the test? Well, lots of things, but there's a lot of easy stuff at the beginning. Don't think it's all super hard word problems. The last 4, the R3s, those are word problems. And we've practiced pretty much every kind. We always try to throw in something that's not exactly like what we did in class to separate the 100%ers from everybody else. But last thing I want to mention is 3D. Do you remember drawing this kind of a picture with 3D? Would you try to set up this scenario? Person's at the base of the pole, and they walk due east. For 40 feet. Then they head due north for 40 feet. Then they look back at the pole and they use their iPhone to figure out how many degrees that angle is. And they realize that it's a 30-degree angle. That worked out really nice. So what was the first direction you headed on the pole? East. If I'm going to call that north, south, west, and east. Then, if you're heading east, be this way. How far did we head? 40. Then we went due north from there, and I'm going to slap down another one of these compass roses quick. Do, and then move it over here. And now, if I head due north, I'm heading this way. And that's a right angle, and that's also 40. Then we went back and looked at that angle right there with the ground and figured out it was 30. Okay, so just some tips on drawing, how to get a 3D picture drawn properly, etc. And now, again, it's not going to just be, oh, it's all about this one triangle. Otherwise, it'd be too easy. Like if we told you the height of the pole is like 25 feet or whatever, well, and instantly you can find this distance, you can find this angle, you can find, so much stuff really fast. We're going to have to give you something where you'll have to like go, okay, I can transfer. If I know this and this, then I can find that, can't I? Because it's a quadratic formula, right triangle. Okay, a squared plus b squared equals c squared. See how it's a right angle right here? See how I got two sides that are the same? Doesn't it kind of look like it's 45, 45, 90 then? So it's probably 45 here and 45 here for the angles. And then I could do the whole ratio thing if I wanted to. Say 1 square root of 2. And 40 is to 1, like, I don't know, is to root 2. Solve it that way. All right. So there's a ton of techniques. I just wanted to talk to you about the three main kinds of setup for these questions. Now I want to give you some that you actually do in class with a partner all the way out to get the final answers for both. And the only thing is, set up the first one, set up the second one, then go back and do both problems. But get the setups done because I want to tell you after about 5 minutes, did you set it up right? And then another 5 minutes, did you set up the other one right? So go through the setup first. Don't try to solve them until you got them both set up. All right, I'm going to pause the video while I hand this out. Okay, this is the part where I get the setup for the first two questions. Just the setup, not the answers. All right, so I am pulling that up right. Nope, that's not it either. My bad. I thought it would go. There it is. Okay, good. So here's the setup. Did you have a 58-degree angle right here and a 25-degree angle right there, and sides of 2 and 7? Do you have that all set up properly? Okay, good. Now, you can, if you want to, try to solve it by dropping a perpendicular here. But, honestly, for me anyway, with this kind of a problem, it all flows easier for me if I now go and make right triangles like here because, hey, I got a side and I know an angle. You know what I mean? Like that angle's just jumping out at me. I could find this side so easily, and I can find that side so easily. And then I'd move over to this triangle and go, actually, that's going to be my final triangle, sorry. I'd move to this triangle, I'll make it in black, and say, I've got a side and an angle in that too. You might not know the angle yet, but you can find this angle pretty quick because it makes 90. 25 plus this angle makes 90, right? So anyway, you'll have an angle and a side, and you can get these two sides. So I kind of like to do this with the method with the triangles around the outside. If you want to go with the one up the middle, go ahead. But I think it'll be harder. All right, so that's the setup on that one. Then here's the setup on the shade problem. Take a look at that one, please. I have it where the sun's on the right side, but you probably have it where the sun's on the left, so I'll switch it for you. Did you guys put the sun on the left? Okay, then we'll put the sun over here, and then it would work either way. Here's the ground. Here's my stick leaning towards the sun at a 45-degree angle, and it's a length of 2. Next, the angle of elevation, there's only one elevation in that triangle. This would be the angle of elevation right there. And it says that it is 30. So that's 30 degrees. That's 2 feet. All right, and Is that all I need? Is there any more information that they tell you? Okay, so that should be all the information you need to find the length of the shadow, and that's this. This one, I do think drawing a line this way is the easier way to solve it. Okay, because then you'll have a side and an angle in a right triangle. One of these two, you have a side and an angle already. Okay, I'll leave it for you to solve it from there. I'll come back on again right near the end of class, and I'll tell you what the answers should have come out to be. I will pause for a moment while you continue. All right, so at the end of the hour, all I got to tell them was the answers for these, and I will do all these problems all the way out in a separate video after school. And this one came out to 1.04, and that one came out to 6.1 and 131 degrees. All right, that's all I got for you for today.